In today's video, we are going to talk about if and else if statements. We'll go through the syntax and logic and common errors that students make. First of all, it's very important to think through your logic before you actually start writing your code. The process of doing this is called pseudocode, and we use it as a skeleton. Now, as we make more complicated code, the pseudocode will be much more necessary. For right now, you might not need to write as much pseudocode, but it's definitely something that we will refer back to. And in terms of why it's necessary, we kind of think about, the process when you build a house. You first have to lay your foundation, then the frame, then the walls. And you're going to finish this house one piece at a time. It would be kind of silly to build the whole house and then check to see if your electric worked or if your plumbing worked. And so the pseudocode helps us make a good plan, and then we slowly do one part of our program at a time. The syntax for an if statement is going to be if, and then we will have some condition in parentheses, and then a statement to execute if the condition is true. Now you'll see here that it says condition must be a Boolean expression. And the Boolean expression could be a Boolean variable, or it could be a conditional to evaluate. So you could say, for example, if num is less than 12. So in that case, what would happen is the computer would check if num less than 12 was true. And if it was true, this code would execute. If it wasn't true, then that code would completely skip. Notice there is no semicolon at the end of our if statement. So this here is an example of an if statement. So if we were to score less than 70%, we would print out a score that you could do better. So essentially, this part would be evaluated first, and if it was true, then this here would get printed out. If it was false, then the statement is skipped completely, and it's as if it never even happened. So those statements that are inside the if statement only get executed if that condition is a true statement. Now, sometimes we'll see this flowchart diagram that we see over here, and this isn't something that I'm ever going to ask you to draw, but it's a layout that I want you to be familiar with in case you see it in a resource. And so this notation, this diamond here, is the condition, and this is what we need to evaluate as true or false. And then this part here in the rectangle is the code that will execute if in fact it is true. So we call this part the condition. That's the part that's up here. And then the body is going to be the actual code that will get executed when it's true. So notice the way that this works. If this situation is true, then we proceed on to this code. If it happens to be false, we skip it entirely and continue on with our program. Now, sometimes you want to have the computer make two choices. In one scenario, do this, in the other scenario, do that. And that's when we would use an if-else statement. So this here is an if-else, and in this case, we have two scenarios that could happen. So if in this case for this scenario, if the amount is less than or equal to balance, if that is true, then we are going to go ahead and execute this code right here. However, if that is a false statement, then we are going to come down and we are going to execute this code right here. When we're dealing with an if-else, you're going to execute one or the other, not both. And that's important to recognize, because as soon as this if is recognized and we go into this red line of code, we skip all of this. And if, on the other hand, the computer came in and this if was not true, then this gets skipped and we would go right here. So we are only going to do one or the other, but never both. Now, another option is we can see what's called an if, else if scenario. And that's what we see in this problem right here. So in this case, we have multiple options. So we have 1, 2, 3, 4, 5, 6 scenarios. So there are 6 scenarios here, and only one will execute. So let's say, for example, we had, let's say, for example, the value of my age was equal to 35. So if my age was equal to 35, here's how the computer would process through this. So first it would say, is my age greater than 65? Nope, so it skips that. Else, if my age is greater than or equal to 40. Nope, so it skips that. Else, if my age is greater than or equal to 30. Yes, it is. So since this is true, then I go ahead and I enter this area of my decision statement. Now at this point, since I have figured out which scenario I fall into, all of this is absolutely ignored. The computer skips over it. It doesn't even bother checking because only one of these options is allowed to execute. And so now we jump on down to whatever code is after this decision statement. And in that case, I would print out age type. So I would print out 30 and fabulous. Now, when we trace if statements, so this phrase, when we say we want to trace the code, is you essentially walk through it like the computer. So you ask yourself, what would the computer do? How would the computer think as it reads this code? All right, so if I were to walk through this like a computer, when I see Boolean failing, I'm creating a variable of the Boolean type called failing. And remember that Booleans can have a value of true or false, and I'm setting it equal to true. So now when I come in here and I say if failing, essentially what's going to happen is the computer is going to replace failing with its value, which is true. So it will say if true, well, a true statement is true. So then we will go ahead and we will execute this line of code. So now I'm going to print out, you should study. And after this line of code has printed, now the computer goes and does whatever is right after the if statement, which says you did just fine. So in this case, we would first print out, you should study. And then after that, we are going to print out, you did just fine, which we know clearly is not the case because we're failing. And so what we see here is this is an example of a logic error. You probably wanted the code to say if you're failing, print out you should study, and then if you're not failing, print out you did just fine. And in order to have the computer decide one or the other, we would need to insert an else in here. However, without having that, it's not going to execute. Or it won't execute the way that we probably intended for our logic. Now, this next line says, after a condition is evaluated, only the line immediately following, the if, that should be an if immediately following the if is executed. So what does that mean? That means that the computer is going to take one line of code. If we want to have multiple lines of code inside of our if statement, which is very common, then we are going to use the curly braces to force the computer to execute more lines of code when that if statement is true. Now, there are several operators that we use with decision statements. And most of these are pretty common to what we would expect them to be in math, the less than, greater than. Since there's no way to do a symbol like this in programming, we just do less than and then an equal sign. Same thing with greater than and equal to. When we want to check for equality, we have to use a double equal sign. And the reason why we need this is because a single equal sign is the assignment operator, which means it actually assigns a value operator, which means it assigns a value to the variable. If I want to check if the variable is equal to a value, I have to use the double equal sign. And that's a really common error people make in programming. They say, for example, if age equals 18, system.out.print, you can vote. All right, so what ends up happening here is that the computer will just assign the value of 18 into age, and then it will say, oh, okay, I did that, that worked, and it evaluates to true. So this will automatically execute. But that's not what we meant. We wanted it to check for equality, so we wanted to have the double equal sign, and that is a very common error we see. Another operator, which you might not be familiar with, is the not equal to. And the exclamation point means not or negation. And so we will see the not used in many ways. This is just one of those ways. And then the other symbols that we will use are the or and the and. So the or is the double pipe symbol. And this returns true if any of the conditionals are true. It will also return true if all of them are true. Now, and on the other hand, and is pickier. It only returns true if all the conditionals are true. And this is something else that we will practice with. All right. Go ahead and pause the video and trace out what you think the output is here. Okay, so in this video, we're first going to, or in this problem, we're first going to see if A is less than B. So we will check 2 less than 4, and that is a true statement, so we enter this line. Then we check if B is equal to C, so does 4 equal 4? Yes, it does. That's true, so now I come down here. Then the question says if C is less than D. So 4 less than 7, which is also true, then I am going to print this. Now, because I entered this if statement, this if and this else, they are blocked together. So since I entered this if, this else does not print at all. Okay, that doesn't go because this if was true, so this else is ignored. And then I'm going to come back out here, and then this line of code will then execute next. So our output will say D is the biggest, and then it will say, when does this print? And many people looking at this code will think that bottom line doesn't get printed because this else statement doesn't execute. However, this line is not attached to this else, and the reason why is because we are only allowed to take one line of code with the nearest if or else. If we want to take more than that, we need to use curly braces. Now, in terms of formatting, we use this nesting to help us better understand our code. And if we would have nested something like this, it would have made it a lot easier for us to understand the intention of the programmer. So I already talked about the double equals is one of the common errors. Another common error is what we call the dangling else. And the dangling else essentially is each if-else statement only executes the line immediately after it. So the else clause is matched to the closest if statement. So even if we indent to show our intention, it doesn't matter. The computer doesn't follow indentation. Remember, the computer ignores white space. So if you are using nested if statements and you want it to match up with an outer if statement, you have to use these curly braces to force that pairing. So let me show you an example of that. If we look at this example on the next slide, when I look at this, based on the way that the indentation is laid out, it appears that the programmer would want this if to go with this else, and then this if would be its own second, conditional. However, that's not what's going to happen. What the computer is going to do is the computer says, well, I don't care how you indented because I ignore white space. I am going to pair this else with the closest if. And so essentially, the way that the computer will treat this would be if the else was right here and this was indented over. And it will group this if with this else. And so if that's what you intended, then this should be tabbed over. If that's not what you intended, then you could fix that by going ahead and by putting curly braces like this. And so what that does is that says that this if statement is inside of here. So then the computer would read it as if else. All right, we're almost done here. So the curly braces are necessary. A lot of times programmers will use them even when they're only doing one line of code. Remember, when there's one line of code, they're not required, but a lot of times people do them just out of best practice. Now, if we have multiple lines of code, then we must use those curly braces. And so this is an example here where I have to use these curly braces are required. And so like I said, a lot of times programmers will just put them there anyways, just to help separate the code and show what belongs to what. Okay, so tomorrow in class, we're going to create a coding bat account. And I have instructions on this slide here, but we'll go through that in class tomorrow. All right, that's all.